Okay, we're recording now. Again, if anybody's listening to, joins us late, we assume if you're listening that you agree to be, to be part of the recording. So here it is. Anyway, this is our logo slide, and this lists the URL of the group. It also lists our YouTube channel URL so that you can get the videos from the YouTube channel. This will be posted in the YouTube channel probably within a day or two after the meeting. So this is the mission of our group, which you've probably figured out, or you probably wouldn't be here if you didn't know the mission, but we're all about learning more about Microsoft Azure. We're about, communicating features to Azure and how to use Azure, and, working with our peers and at all different levels. So there's really, it's all about education and informing and community. Providing a forum for open discussion and informal networking, which again, like I said earlier when we started this meeting, that we had a networking session this morning. I'm sorry, this evening before we started the recording. I think it went pretty well, so we'll probably continue that. Azure Group Logistics, as you probably also know, we normally meet up at Microsoft at this time and date every third Thursday of the month, but we're not, we're not doing that anymore. We're doing online meetings during the pandemic. So we did networking tonight, but we can't give you any food, obviously. So that's why I crossed off food there. All right. So that's what we're going to do. We meet online. We have more than 1,600 registered members, which still blows my mind. Roger will testify to the fact that we started back in 2013 with 4 people, right, Roger? Okay, all right. And even though we have over 1,600 members, we don't get them all to show up at a single meeting, but hopefully we get a bunch. Like I notice we've got about 15 people online right now, which is good.
And some more will. Feeding kids.
Okay. Yeah, you didn't get your cue, right?
That's right.
Okay. And Roger and I are the only 2 survivors, right, Roger?
Yeah, we're it.
Okay. So anyway, yeah. We want more members. We're greedy. Okay. Tell your friends and coworkers about us. Bring your friends. Bring your relatives. Whatever. Anybody who wants to know anything about Azure, bring them. Also, a lot of people have ideas for future topics. That's great. I like to give preference to people who actually show up for a meeting to give us advice on what the next topics should be. Now, up until the pandemic, we'd been doing like 1 month at a time. So we had a speaker lined up 1 month ahead. Now it's an unusual state. We've got people from other areas of the country presenting, and we've also got speakers up through October. We don't want to have a second meeting every month. We talked about that. So, but we can start scheduling monthly, after that. So if you have topics that you're interested in that you want us to cover, take a look at the past meetings we've had, and take a look at the the videos in the YouTube channel and see what we've covered already, and then make suggestions as to what we should cover. This is the board of directors. Okay, it's myself. I'm the founder and the president. I'm currently a cloud solutions architect at a company called RedApp, a large 260-person consulting firm here in the States. Microsoft's silver gold partner. Roger, as you talked to a few minutes ago, Roger's co-founder and president and vice president. Sorry, and he works over at Deloitte. Where is it? It's in Hermitage, right, Roger?
That's right.
Yep. Tim Warner, a lot of you probably know Tim Warner. He lives here in Nashville, but he's really well known because Tim does a lot of the Pluralsight Azure courses that you find up on the Pluralsight site, which, by the way, I happen to love. I've had Pluralsight this is not a paid political announcement, but it's a paid, but it is an announcement. I've had Pluralsight for years, and I find it very useful for learning. So Tim is a board member. He's also graciously contributed this team site for us to use, since we don't have our own team site. And he'll be the one posting it up for us on the YouTube channel afterwards. Okela Alred is another board member, and she's our director of academic outreach. She works with the colleges and universities in the area and the people like the Nashville Software School and so forth to help bring in new members. Matthew Puckett, if you're in the Nashville area, you might know Matthew. He's local too, but he's a black belt Microsoft Cloud Solution Architect. Actually, his title is officially Principal National Cloud Solution Architect. And he's been with the group from the beginning too. He's our meeting space sponsor when we meet up at Microsoft. And another board member that we have is Vaco. Vaco has been our sponsor since 2013, since the beginning. You know, I've run user groups in other parts of the country where I've always had to scrounge around for refreshments for meetings, and thanks to Vaco, we haven't had to do that. So again, a big shout out to our sponsors: Microsoft, Vaco, Tim. By the way, techtrainertim.com is Tim's site where he has a lot of training materials as well. And RedApt, who graciously lets me work on this during work time. So that's a pretty good deal. We were starting up a sponsorship program. If your company wants to sponsor something for the group in exchange for a few minutes to talk about your company at the beginning of the meeting, we want to try to get that started. Roger is going to spearhead that effort. So if you have an idea, you got some swag or a $50 gift certificate that you want us to raffle off or something like that, we can we'll accommodate you, and we'll mention you in the meeting. Okay. Upcoming meetings, we've got 2 meetings scheduled, September and October. Vibhav Gajira is a platform architect with Qt, and he's going to talk about Azure networking. And then John Bowker is actually a security officer in a company called N-Contracts. And he's going to do a deep dive into Azure security. So those are the 2 we have. So from November on, we're open. So again, make your suggestions if you have them. And with that, I'm going to turn the stage over to our featured speaker tonight, who will tell you all about Don't Pass on PaaS. And let me stop sharing, and you can share. How's that? You stop the sharing. You can share. Okay.
All right. Thank you, Bill, and good evening, everyone. If you were around for the social part of the session, then you might have already seen me. I turned on my camera for a bit. If that creates a problem for bandwidth or something, I'll turn it back off. But I wanted to at least get started like this, give you an opportunity to see who I am, who's talking to you. So like Bill said, my name is Sven Aelterman. I'm a cloud solution architect at Microsoft. Specifically, I work with our United States education customers, that's K through 12, as well as higher ed, and somewhat by extension of higher ed, also academic medical centers. And if you want to know a little bit more about me, such as LinkedIn or GitHub or Twitter, things like that, the website there, the short URL, I'll take you to a page that's a little bit about me. I figured I'd just throw a few things out there. I very recently moved, actually about 3 months ago this weekend, moved to Mount Juliet, so right off the east side of Nashville. I did that when I moved to Microsoft. Prior to my position at Microsoft, I was the director of IT for the College of Business at Troy University in Troy, Alabama, which is also where I lived for quite a long time. Originally, I'm from Belgium, and if your eyesight is quite keen, then you'll see a little red dot on that world map. That's where Belgium is. And so, even though I'm new to Mount Juliet, I'm excited to get engaged with some of these meetups, some of the user groups. It's something that I very much enjoy doing. When I lived in Alabama, I've been speaking at code camps and SQL Saturdays and user group events. I think actually 15 years last month. So I've been on that track for about 15 years, and I've enjoyed that very much. I enjoy the networking. I enjoy meeting people and hearing your stories from the trenches. So very excited to begin participating at the meetup scene here in the Nashville area. Now, even though I work for Microsoft, one thing I need to add here is that any opinions that you might hear me express this evening are entirely my own, not necessarily reflective those of my employer or colleagues or partners, etc. I've had the opportunity to co-author a few books with people who are much smarter than I am, but I guess needed some extra keyboard time. So one book that I co-authored was The Art of SQL Server File Stream. Bonus points for those of you who know what file stream is. With Jacob Sebastian, that was actually back in 2012. And then a little bit more recently, I've co-authored for Microsoft Press SQL Server 2017 Administration Inside Out series. So 2017 and 2019 came out most recently. I think it came out probably about 4 months ago now or so. And as you can see, as SQL Server becomes more complex and runs on Linux and includes big data, the list of co-authors there seems to increase. So please don't expect that I know everything about SQL Server 2019. I know a slice of it. That is a slice that I authored. Now, what I would normally do is talk a little bit about what Azure is, but then I thought, well, for this audience, why am I talking about what Azure is? You've probably already heard that many times. So I thought, well, maybe what I'll do is share a few resources that you might or might not have heard about. So hopefully out of these 4 resources, one of them will be new to you. And at least you'll have taken away one new thing from my presentation this evening. The first one is Azure Charts. AzureCharts.com is a service that actually collects lots of information about all the different Azure services that exist. Some of it is information about where you can take courses about that Azure service or announcements, new features that have been related to that Azure service. So there's all kinds of components there. So well worth checking out if you haven't seen it yet. It's called Azure Chart because it's presented in a bit of a graphical format, so it makes it very easy to just explore, click around. It's very kind of go down a rabbit hole and learn something new. It's a good way to spend a few minutes of your day if you're involved with Azure. Now, second one is Azure Academy. It's a YouTube channel that is run by one of my colleagues at Microsoft, Dean Safola. And by the way, Azure Chart is actually also run by someone at Microsoft, a cloud solution architect called L.L.C. Now, Azure Academy YouTube channel, I like it a lot. I watch regularly the new releases of videos. They are organized by broad topics such as networking or virtual machines or Windows Virtual Desktop, areas like that. And they're usually limited to about 20 minutes. So they're really good nuggets, but they contain a good bit of technical depth. So they're not introductory videos per se. Now, there might be some, but there are quite a few intermediate and advanced content videos on Azure Academy. Next one that I wanted to point out, which I think is probably one of the lesser known ones in this list, is Azure Citadel. And it was started by cloud solution architects in the United Kingdom, but has grown to be more of a community effort since then. Other people at Microsoft are participating in community at large. And Azure Citadel is great because what it does is it gathers and creates hands-on labs around a variety of topics. So if you wanted to get hands-on, guided step-by-step on Azure networking, for example, then there's a step-by-step guide for that available that helps you go through learning the networking technology that's in Azure like that. So if you like step-by-step guided hands-on learning, then Azure Citadel is something that I would encourage you to check out. And since I'll be talking this evening about application development, I thought the last resource I would throw in there would be about the Azure DevOps self-assessment. It's a site that is run by Microsoft. It's not necessarily very Microsoft-centric. It's about DevOps. It allows you to take a survey, actually one of 2 surveys. There's a shorter version and a longer version. And the survey is built by asking you questions about your current practices as it relates to application development and managing of applications in your organization. When you get to the end of the assessment, you'll receive a chart that highlights your relative maturity on 7 different areas, and then provide suggestions as to where you can, or next steps, I should say, you can take to become more mature in the areas where you feel you could benefit from some improvement. The DevOps self-assessment by itself could be easily tricked. I mean, if you wanted to score 100% on everything, I can tell you right now, the last answer in the multiple choice list of answers is always going to be the most mature one. and the top answer is always going to be the least mature one. So it's not that difficult to trick or get a high score if you wanted to get a high score. But I have taken the assessment for a fictitious organization that I might run in my mind, and I found it to be really valuable. The descriptions of the different areas that are covered, 7 different areas that are covered, are quite detailed and quite helpful. So like I said, I hope that at least maybe one of those 4 resources is new to you, and that you'll be able to benefit from that. Now, I'll briefly talk a little bit about what I wanted to do with this presentation that I've titled Don't Pass on PaaS. And of course, I think that's a very clever title. But it's kind of geared towards application developers or architects for you or in your organization. And the idea is that a lot of applications that already exist, that are out there, can migrate to the cloud. Right? If you can run it on-prem, in many cases, you can run it in the cloud, because all you technically have to do is spin up a virtual machine or multiple virtual machines, and you can migrate that application to the cloud. And a lot of organizations do that. However, in order to really begin leveraging some of the benefits of cloud infrastructure, platform as a service offerings are more attractive from a perspective of cost, scalability, disaster recovery, of course, new feature set, new capabilities, flexibility, agility, things like that. And when you have the opportunity to do a greenfield development, then those things are much easier to begin leveraging. But what I wanted to talk about tonight is just a few thoughts, and there's of course dozens of Azure Platform as a Service offerings that we could talk about. I'm going to talk about some of the more foundational ones, some of the more common ones, and how you might begin to think about implementing those in your applications. Now, it could be a brand new application that you're developing, certainly, but also could be if you decide it's time to refactor a portion of your existing application to begin leveraging some of those benefits that the platform as a service offerings have. So the first thing I'll talk about is Azure Storage. That is probably, for any cloud service, the most foundational service, right? Now, in particular, Azure Storage, what do you store in there? No surprise to anyone, I suspect you store blobs, right? So any byte stream can be dumped in Azure Storage. Azure Storage also contains a file share component, supports the SMB protocol, and more recently in preview now, NFS protocol for file shares. So you can use that for scenarios where an application or users perhaps are simply used to actually using file shares, and maybe you can't go cloud native with the storage, but you still want to take advantage of the capabilities of Azure storage accounts. So that makes a lot of sense. That's probably not surprising to anyone that those are 2 types of data that you can store in the cloud. On Azure, a storage account also allows you to store table-based data. A little more than key value pairs. It's essentially row and column oriented type data. It's not relational data. The tables are independent of each other, but that's another type of data that you can store in an Azure storage account. And then finally, the 4th type of data that you can store in an Azure storage account is a queue. So essentially sending messages to a queue and having another process, another application perhaps, offload that or dequeue those messages and process them further. And that's the example that I wanted to use this evening, the queue example. I thought You probably have already seen lots of examples of Azure file shares and Azure blob storage. I don't know if you have heard a lot about Azure tables, but I decided to go on the queue side here. And specifically using queues to offload work, in my case in a web application, although of course the type of application isn't really that important. So conceptually speaking, what I'm working towards here, and I'll share the application of course in just a minute, but what I'm working towards here is the website that has some long-running process. And as we know, a website that performs some type of long-running process sometimes doesn't result in a very suitable user experience, especially if it's synchronously done and the user needs to wait for the process to finish before the website becomes responsive again. So the way that you can work around this, leveraging Azure Storage queues, is by queuing a message from your application and then processing that message in a different application. And specifically in this case, on this diagram, I've put in an app service, which is perhaps running your main website, that is responsible for starting that long-running process. But instead of actually running the process itself, we're sending just a message to a storage queue. And on the right-hand side, I've included an Azure Function app, and the Azure Function app is what is going to check the queue, or actually, I should really phrase it correctly, the Azure Function app is going to be triggered when a new message arrives on the queue, and the Function app can then do the processing on behalf of the website. Now, I want to make it clear that there's certainly no restriction that it has to be an application service. Could be any application that takes advantage of storage queues, and there are other ways to process the queue than function apps. But if we're looking at application modernization, certainly a function app, which is serverless technology, is a good choice to go for doing that. Also, technically, there's absolutely no requirement that your application itself would actually live in the cloud. It's certainly possible for your application that sends the message to the queue to run on premises and have the queue and perhaps the function app that does the actual processing live in the cloud. So I'm going to switch to Visual Studio, and now I'm myself try to be sensitive to making sure that I don't show things that become an eye test. The Visual Studio environment itself shows probably fairly small on your screen, but I have attempted to at least begin setting my zoom level and font sizes appropriately. So hopefully you can appropriately read the code that I have here. I'll actually first run the app, and it's nothing special. Even though I have an application development background, I am not a master UI builder, or in this case, I haven't really done much to even spruce up the app in terms of logic. So I've taken the default ASP.NET MVC core or ASP.NET Core MVC template project and just made a few modifications there so that I have a framework to illustrate what is going on with this app. So if Murphy's Law doesn't kick in, we should be seeing the homepage of the app appear any second. Okay, there you go. Hopefully it won't take that long every time I need to run it. And if you can hear the dog barking in the background, my apologies for that. My family is just coming home, so the dog gets very excited from that. Now, like I said, nothing special about this application here. It allows me to sign in with an Azure Active Directory account in this case, and virtually no menu to speak of. And it displays some kind of customer count. We'll get to why that's there later near the end of the presentation. And then I have a link here that begins a long running operation. So I'm going to click this link, and 2, 3, 4, 5, takes about 5 seconds and then I get a success message back for this long-running operation. So probably not the best user experience, even though it only takes 5 seconds. 5 seconds in web time is probably more like 2020 has been so far compared to other years, right? It feels like an eternity. So let's see if we can make a few changes to improve the user experience for this. Now, I'm going to admit that I've stacked the deck a little bit in my favor. What I've done, of course, is I haven't made my business logic all too complex. And I also haven't necessarily done something on the confirmation page that relies on the output of this long-running process. Now, if I had done that, there are of course still ways that I can use queuing, for example, by then polling in my application perhaps with some type of notification service, all types of frameworks that will allow you to do that. It's a little bit outside of the scope of what I'm talking about this evening. Now, I'm going to scroll down, and here is my controller method called long running. So that is the method that is triggered by clicking that link on the home page. And perhaps there's some code, some logic here that is specific to the web application. So maybe setting the value of a variable to 5,000, and maybe only the web application can do that. Okay, perhaps you could also imagine the 5,000 actually is input from a user, perhaps something along those lines. But then my controller method is going to call some type of logic that takes a long time to execute. And I'll let you see the way in which I have implemented this. I'm essentially just sleeping the thread for as many milliseconds as the function argument is passed into. So nothing fancy going on there, but perhaps not something unsurprising. So can we make that better? So in this case, again, I won't harp on the same point over and over again, but I did stack the deck a little bit in my favor by essentially not making the output of this controller, or the view, I should say, that this controller ends up dispatching by not making it dependent on any of the outputs of this method. But we'll take a look essentially at how this works with queues. So the first thing I'll go ahead and do is also show my web browser, and I realized that's still a little small. So hopefully this makes it easier to see. So I've prepared a few resources here, and one of the resources that I've prepared is a storage account. And when you look at this storage account, there's lots and lots of settings for storage accounts related to security and networking, and it's even possible today, if you haven't seen this before yet, to run an entire static website off a web service, off a storage account is a very effective, cost-effective way of running a static website in Azure. But if we scroll down a little bit, I've got blobs and files and tables and queues. So in this case, I'm interested in queues. So take a look at what queue that I have used here. And so there's a queue called long running. So I'm not going to go through the entire process of showing you how to create a queue and what all of the potential capabilities of a queue are. But a queue has a name. That's the important part. And of course, it lives at a particular endpoint, which is the URL of the storage account with the word queue stuck in that URL. So that's how your application can access a queue. Now, because I'm using .NET Core, and many of you might be using Java or Node or even other languages, there are SDKs available for many of these languages. So a lot of the implementation details of how to actually send messages to a queue are somewhat irrelevant for us. But suffice it to say that everything is based on REST API calls. Now, I'm going to begin by actually commenting out this line of code that I'm trying to get rid of. And I'm going to just show you what I've done here. So I'm calling a method called add to long running queue. T, of course, has to pass in the same value that I was going to ordinarily pass in. And I'm calling that on a queue object. Now I'm going to talk about how I got that object in a little while, because one of the things that I'm also aiming to do is share perhaps a few best practices with you this evening, and I'm hoping to have a discussion about this too. So I'm certainly don't want anyone to be shy about raising a question. Even when I'm chatting, I'm trying to keep an eye on hand raising and meeting chat. So would love to hear from you about anything that that you might have a question about as I talk about this code or the concepts. So like I said, I'll talk a little bit about how I got this object in a few minutes. But first, I'm just going to show you what my code looks like. This object is essentially an instance of a class that I've written myself called Azure Storage Queue. And Azure Storage Queue is something of a very lightweight wrapper that I've written around the available SDK, in my case for .NET. And the SDK makes a class available called QClient. And the QClient class allows me down here to send a message to the queue. And I'm doing a bit of an amateur thing here. Not all of my code is best practice. I'll say that up front as well. Doing a bit of an amateur thing here and just sending some JSON. There's of course much better ways to do that, but this is not a talk about JSON. So I'm just kind of handwriting or hand parsing, I should say, or constructing the JSON. So essentially creating a time property in the JSON file and sending the value of my T parameter into that. Now, this queue client certainly needs to understand where that queue actually lives. How does the queue client get to the queue? And I'm solving this problem using, in my case again, trying to demonstrate a bit of a best practice here. In my case, using the options for configuration, but that's a bit much to get started with. So we'll kind of ignore where this connection string comes from. Okay, we'll just need to understand that the connection string is going to include the name of the storage account and is going to include the credentials that are needed to get to that storage account. So for now, we'll just leave it at that. And so when I create a queue client object, I'm passing in that connection string, and then I'm also going to pass in the name of the queue that this queue client is going to be representing. And then finally, what I'm doing is I'm just doing a quick check to see if the queue itself does not exist. I'll just go ahead and create it. Okay, I can pass in some metadata about this queue that's in a dictionary. So pretty much a key value pair dictionary, and I'm not putting anything of value in here. It's just for demonstration purposes. So because I'm doing this in the constructor of my Azure Storage Queue class, it means that any future method will have this instantiated queue client available. And so that's how I can manage to simply call send message and get that onto that queue. Now, when the queue, there's no return value, as you can see here. I might, actually have a return value potentially that I could process. It's possible. I didn't do it here in this instance, but there is a and again, I understand this may be a small font, but the return value of the send message method on the queue client is a send receipt. so I can analyze that send receipt to see if there was any potential type of issue with that sending. In this case, I'm just assuming everything is going to go okay. So when I get then back to my home controller, I can simply return the view. Now, in other words, as long as adding this message to the queue takes less time than the actual long-running method, I'm going to come out ahead. Now, before I can move on and run my code again, what I do want to show is how I'm configuring the URL to the storage account. And let's see. Yeah. So we go ahead and move the commenting here. Actually, this should also go in the app settings file just for completeness. So I was surprised it wasn't there. That's okay. Now, in this case, something else that I wanted to share here is that this connection string doesn't actually include what I said it should have included, namely a URL and some credentials. In this case, it just says use development storage equals true. So this is a feature of the Azure storage accounts that essentially leverages the emulator. And I realize again that maybe my font here is a little low, so hopefully this is better font size for you. So the Azure Storage emulator is something that gets installed, for example, as part of Visual Studio with the right workload, but you can also go and download it separately. And when you start the Azure Storage emulator, the first thing it's going to do, if this is a new installation, in this case it was a new installation, it is going to create a database with a particular name in your local DB instance of SQL Server. So that is quite handy because essentially that means that this Azure Storage emulator can emulate storage not just temporarily or ephemerally, but actually long term. Now, in addition to queues, I can actually also use the storage emulator to actually emulate blob storage, for example. Now, when I look below here, there's some other commands. I'm not going to go into any of these, but some are very obvious, I suppose. Start and stop it after it's been initialized, looking at the current status and clearing everything. I'll just look at the current status, make sure it's still up and running. Oh. Oh. I don't feel like figuring out where I made a typo. So I'll just do this. Okay, there we go. So I get some output back. It tells me that my storage emulator is running, so it's ready to accept connections. And the connections are in fact over HTTP. And I have a blob endpoint, a queue endpoint, and a table endpoint. So the only thing that's missing from the emulator is a file endpoint, but that just emulates a file share. So that's easy enough to emulate on premise anyway. You don't need to have a special emulator running for that. You can also see that each of the endpoints has its own port number. So in this case, port 10,001 is where my queues are running. Now I'm pointing this out because this is going to come back later in the presentation. Okay, so now what I can do is demonstrate how much quicker this application should run. Now, hopefully it'll also start up much quicker now that my development machine is hopefully warmed up. Let's see if that's true. It's not much quicker. Hopefully we won't have to wait too long for this home page to load again. I know it's going to sound like an excuse, but needless to say, when I was testing this half an hour before the start of the meeting, this took a few, I don't know, few seconds at most. Well, let me show you something else while this loads. I don't want to spend a whole lot of time talking about how we might actually go about processing the queue messages, but I did set up an Azure Function app, actually here in the same Visual Studio solution. And in the Azure Function app, I have, well, not a very appropriately named class called function1. And this class called function1 has exactly one method in it called run. And that is by convention the method that's a good idea to use. It's possible to change it, but the default one is run. And what I've provided here is the name of my queue, long running. I've left the connection string empty here. Like I said, I've just set it up for a demo, but this is where the connection string would go. And needless to say, we wouldn't want to hard code the connection string, but actually retrieve it from configuration somewhere. We'll talk about that in a little bit. That will actually return the JSON string that has been posted to the queue. And I didn't spend too much time actually making this work. I'm not actually parsing this my queue item to retrieve this time value, but what I can do here is instantiate my logic class and call the long running logic and let it take 5 seconds or however long it needs to take in the backend without blocking my web application, which we'll take a look and see if the web application has come back. There we go. We're going to take a look and see if all the pages load slowly or no. Interesting. Seems like it's just the first startup that's very, very slow. So I'm going to begin a long running operation. And even though technically my site is somehow executing the same operation, it becomes responsive. It responds a lot faster. So if I don't need my users to know anything about the success of the long running operation, this is a much quicker way of doing it. And what I also wanted to show in relationship to storage accounts is the Azure Storage Explorer. And I probably think for anyone who's been around Azure for a while, hopefully already knows about this tool. The Azure Storage Explorer is, let's see if I can get this to drag to the other screen properly. Okay, there we go. So the Azure Storage Explorer is a tool that you can use to explore actually multiple types of storage. It was originally for storage accounts, but now you can also explore Cosmos DB, data lake storage, which really is a storage account, and other types of storage within Azure. And you can also connect it to the local emulator, which is what I have done here. So I have connected it to the emulator, and here's my queue that is called long running. And currently I don't have any messages, but if I hit refresh, you can see that the message has been posted on my queue. And if I did in fact have some type of function app running on a queue in Azure, that message would get picked up by the function app, would get processed. So that is a way in which you can use one of the foundational services in Azure for the benefits of even an existing app with a little bit of refactoring. You can do that and make your app more user-friendly. All right, the next service that I wanted to highlight is Key Vault. And the reason I wanted to highlight Key Vault is because Key Vault is a common answer in Azure to a very common problem. Namely, my app has secrets that need to be securely stored. How do I do that? Now, secrets is kind of this generic term. So what could it be? Well, in the case of Key Vault, really anything could be a secret. Specifically, there is a concept of secrets in Key Vault, and that you could use, for example, to store access tokens that your application needs to cache to call third-party APIs or API keys. such as like bearer tokens, for example, could be literally anything, including the connection strings that your application needs to use. If those connection strings contain secrets, such as they might for a storage account or a database connection string, then you would go ahead and use secrets in Key Vault for that. You can also store X.509 certificates in Key Vault. And centralizing your certificates in Key Vault has some advantages in terms of when renewal time comes and so on. It's easier, especially with other Azure services, to manage those certificates. And then finally, keys, as in encryption keys, can also be stored in Key Vault. And within Azure, they're used, for example, if you bring your own encryption key for a SQL offering in Azure, or even for Azure Disk Encryption. Those keys can be stored in Key Vault. In addition, Key Vault actually integrates with lots of other services, including, for example, storage accounts. So it's possible for a client that leverages storage accounts to simultaneously leverage Key Vault, encrypt the blob on the client side using a key obtained from Key Vault, and send the encrypted blob directly to the storage account. And then, of course, when it comes time to read the blob out of the storage account, again, through the same integration with Key Vault on the client side, the blob can be decrypted, of course, provided appropriate access to Key Vault. Other integrations include App Service, for example. I can store my secrets in App Service directly into Key Vault. Now, the example that I'm going to use here is going to be storing the storage connection string securely from within my app. Now, you'll remember I showed you the storage connection string that is here in my app settings, for example. It doesn't actually contain any secrets, it just says use development storage equals true. But I don't think it takes much to imagine that if I had a connection string that was actually used in production, that there might actually be secrets in there. So the first thing I'm actually going to go ahead and do, just so you see I'm not tricky, I'm going to go ahead and comment out the current connection string. So there we go. I don't think I need those files anymore, so I'll go ahead and close them. Now, there's multiple ways to begin configuring Key Vault, and Key Vault, just like storage, is completely REST API based. So if you happen to use a development framework for which there is no SDK available, no Azure SDK available, you can always make the REST calls yourself. Again, in most cases, that's not necessary. .NET, Java, Node.js, others have SDKs available for these Azure services. Now, in this case, what I've decided to do is I've decided to use a Visual Studio feature called Connected Services. So in the Connected Services settings of my web application, you can see that I have configured Azure Key Vault to point to a specific Azure Key Vault. I'll demonstrate that in just a moment. And I'm actually pointing to the Key Vault using an environment variable. So while this provides me with a graphical user interface to configure Key Vault and make it available within my application, there's really no magic going on. In the end, everything is still stored in code files. So for example, in the properties, when I go look at launch settings, I'll focus on the, oh, that was a little fast. I'll focus on the web application here. In the launch settings, the environment variable secure store :URI is being set to the specific Key Vault URL that I'm using in this project. And the service dependencies is a different JSON file that actually just tells Visual Studio for later what those service dependencies are. Okay, and another thing that my that this Visual Studio wizard, if you wish, did. Oh, I'm looking at the wrong one. Is configure my startup for my web application to specifically, and it's these lines of code here that have been added, to create a key vault endpoint, which is simply a instance of the URI class, the standard .NET URI class. It retrieves the endpoint from the environment variable called secure store URI, and then allows the configuration in ASP.NET Core to take advantage of the Azure Key Vault. Okay, and in this case, I'm accessing this with my default Azure credentials. But again, while I've configured this with a graphical user interface, it's really just what is done for me is add a few lines of code sprinkled throughout my project to make it easier for me to manage that. It also has a few advantages when deployment time comes, because when deployment time comes, I can then provide different values if needed, or I can make sure, for example, that this environment variable would be available in my deployed application or to my deployed application. So that's the road I've taken here to make it a little bit easier not to have to write the code myself, but it certainly wouldn't have been a stretch if I had to do that. Now, how does this now actually work? I've disabled the queue connection string that I had in my app settings. Now I need to put that same value somewhere in Key Vault. So I'll show you what my Key Vault resource looks like. So this is the Key Vault resource that I've created for this application. And as you can see, there are keys, secrets, and certificates. Those are the three types of secrets that can, well, and I kind of hate to use the word secrets in both of these contexts, but those are the three types of elements that Key Vault can store for me. I didn't store any certificates, or actually I also didn't store any encryption keys. All that I have for this application is a secret. And here is my secret called Q --, and this is important, I'll say in a minute why, connection string. So this Q connection string, actually I've messed around with it a little bit. One of the things Key Vault does is automatically keep older versions of my secrets for me. And I can go look at the current version of the secrets, and I can actually look at what the current version of the secret is. As you can see here, it's of course the same connection string that I used to have in my application settings files. Now, what is the deal with that name? Why is it called Q --, connection string? So it's probably time very quickly to discuss this. It's important if you were trying to do this on your own. You can see here what I had originally in .NET was a set of nested configuration items. So I had the property connection string in my JSON actually as a child property of Q. And the way I would access this in my application, if I needed to manually get to that configuration item, is to use Q -- connection string. Now, unfortunately, in Key Vault, I cannot use that colon in the middle. That doesn't work. I can only use alphanumeric characters and dashes. And so there's a convention that's been established for this provider, this Key Vault provider for configuration, that I'm going to replace the hierarchy that is normally separated by a colon by 2 dashes. Okay, so that's where that name came from. That's why those 2 dashes are there. Okay. All right, so in the interest of time, I'm not going to rerun my application. It's already essentially set up because I literally have to do nothing different. The fact that during the building of my hosting environment for my web application, the fact that this line of code is here pointing to that Key Vault URI, that is enough for me to be able to keep using the same the same string that comes out of my configuration. Right? It does not change. So this connection string is going to look essentially like a Q colon connection string. And I just realized I didn't spend any time actually talking about where this I options come from. If there are any questions about that, then please let me know. I'll be happy to demonstrate how I've done that. But it's essentially a combination of dependency injection with strongly typed configuration elements. Okay. So that's a little bit about Key Vault. Again, at a high level, a very quick way to modify an existing application to store secrets more securely. You can essentially, doing this, remove the secrets entirely from your application. Now you might wonder, wait a minute, have I just moved the goalpost? Now all the secrets that my application used to have, perhaps in configuration files, are now stored in Key Vault. However, what about access to the Key Vault? Surely the Key Vault itself needs to be secured. And of course, the answer to that is yes, you need to secure the Key Vault. However, you can do that in one of two ways. During development time, your development environment can essentially use your Azure Active Directory credentials to access the Key Vault on your behalf. So in other words, while I'm a developer, or while my application is running in my development environment, the developer has to have access to read the secrets from the Key Vault. Presumably, it wouldn't be the production Key Vault, but it would be a Key Vault set up just for the development environment. And then at production time, I can configure my application either with just a single secret to be able to connect to the Key Vault, or even better, if my application is running in Azure, which again, otherwise is not a requirement to use Key Vault. But if my application is running in Azure, I can give my application a managed identity or a user identity, and the application can use that identity to securely connect to the Key Vault instance and retrieve the secrets that it needs, without needing to specify any type of, well, other than the URL to the Key Vault, but without having to specify even a username and certainly no password or some type of access key. The application automatically handles it for me. So I think that's a very powerful way to do that. And you can see with a few lines of code in most applications where there is an SDK, in most frameworks, I should say, where there's an SDK available, I can go ahead and implement that. Now, the last service that I wanted to highlight in tonight's presentation was Application Insights. And Application Insights is an application performance management tool. And we can talk at length about what application performance management tools actually do. And at a high level, they allow you to instrument your application so that many types of telemetry are going to be sent. Think of it as log files, but on steroids in a sense. And then, of course, analyzed, right? We can't just send it to a black hole. We need to be able to then retrieve that telemetry and analyze it and take some actions based on what the application has been notifying the application performance management about. I also, again, want to make very clear that Application Insights is one of those services that does not require your application itself to run in Azure. If you have an application running on premises and you want to keep it on premises, it's not a problem, but it does not prevent you from sending telemetry data to Application Insights, which of course Application Insights will run in Azure and have the capabilities available there. So a few of the capabilities of Application Insights is that it can create not an application app, but an application map. So it can create an application map by simply observing what your application does. A newer feature, which I can't speak to exactly how many development frameworks or application frameworks that's available for, but certainly, of course, for .NET, it can actually collect snapshots of your application while it's running. Now, that is extremely powerful because that means that when there's an error in your application, And I certainly don't mean to insult anyone and insinuate that you run or develop applications that produce errors, but there are such developers out there. So when that happens in your application, Application Insights will take a snapshot of the running state of your application, including the values of variables and arguments, parameters to functions, and so on. And so you can actually replay the steps that led up to the exception occurring. Now that to me is immensely powerful. I suppose that could make me a poor programmer, that I need to do that in the production environment, capture the values of variables, etc., to be able to troubleshoot any problems. But I can certainly tell you from firsthand experience that it's very, very powerful and very, very useful if you're scratching your head over what is happening, what is causing perhaps exceptions in your application code that you can't replicate any other way. In addition to that, there's also website analytics built in. So if you're talking about a web application, and again, I probably didn't make that clear in the beginning. So your application not only does not have to run in Azure, it doesn't have to be a web application. Any type of application can send telemetry to Application Insights. But if you do happen to have a web application, what Application Insights can then do for you is automatically analyze the flow that a user follows in your application. And also the Application Insights can track the retention analytics and other statistics that are relevant for websites. And then finally, truly any custom data. You could send any telemetry just like you would send something to a log file, maybe using Log4Net or other types of logging tools. You can send that to Application Insights. Now, talking about Log4Net, the next best thing about Application Insights is that if your application actually uses Log4Net or select other logging tools, there are actually functionality available in the Application Insights SDKs that you can simply use to take whatever Log4Net might have normally written to your normal output, maybe a Windows event viewer, maybe a log file, maybe a database, and actually just send it to Application Insights. So very powerful capabilities, again, especially also for existing applications. You don't have to rewrite all of your logging infrastructure if you want to take advantage of those Application Insights. So in this case, very simple addition to my architecture diagram, I'm going to add an Application Insights instance connected to my app service, and really without writing any additional code, App Insights is going to start working. I also want to make it clear that the application that I'm demonstrating here tonight, the code that I'm demonstrating here tonight, is actually not even running in app service right now. Again, I've just demonstrated this as one potential way to run an application in Azure using app service. It makes it a little bit easier to get very valuable telemetry from App Insights in many cases, but that is not necessary. So like what I've done before, I'll quickly jump into the portal and show the Application Insights instance that I have. And it's not been up and running for long, and my application, of course, has no real traffic other than when I hit run on it. But I'll see here if I can show a little bit of data. So here we go. When I was setting up and getting ready for the presentation, I managed to have a failed request, for example. Also, I have been measuring my server response time. And I'm actually glad I did that, because I'm sure most of you are thinking that there's no way that it ran slowly just during the demo, but actually Application Insights comes to my rescue and clearly shows that the response time on average in these earlier timeframes was, well, I guess right around 5 seconds. And then of course it all of a sudden started jumping to many, many more seconds. So very interesting to see how that application has been responding. And of course, it also just counts the total number of server requests. So this comes out of the box. Another thing that you will see here is an application map, which is a visual representation of your application in the center. And at the same time, also Application Insights has automatically detected for me which other types of dependency, I call it dependencies, but which other types of resources that my application is accessing. So my application's here in the middle. Okay, you might remember this port number, or I should say this URL port number. This is essentially my call to my storage emulator. So if I was actually running this app in production, it would of course tell me which storage account this was, rather than giving me my localhost URL. And then another thing, we haven't seen it yet in the application, but one other thing, my application is actually speaking with an Azure SQL database, and those calls are also being captured, and I can get some data for that. So for example, I can see that the calls to my storage account take just under 2 seconds. I can also see that the calls to my Azure SQL database take about 186, and I realize this is an eye test, but anyway, about 186 milliseconds. So accessing my Azure SQL database is very, very fast, even though my Azure SQL database is actually running in Azure and not on my local development environment. And then I can investigate these failures here. So my applications encountered a failure a while back. Let's see, I'm going to make sure that I have the correct time filter set. Okay, so there we go. So when my users have requested the URL home/fail from my application, the 2 out of 2 times that has happened, it has in fact caused an exception. And I can see that in both of these cases, the response code that my web server ended up sending back to the client was an HTTP 500 code. I can also see that the exception type that had been thrown is in, well, can't really see it, but it's cut off. But anyway, it's an invalid operation exception. That has happened twice. So both times it was the same type of exception. Now I can actually drill into those operations. I can actually drill a little deeper and see, okay, well, which one of those do I want to drill into? Doesn't really matter. They're both virtually identical. So I'll just pick the most recent one. And when this loads, and this doesn't look very attractive because I've zoomed in quite a bit on this screen, so I'll make it a little bit smaller. Let me see here. Okay, there we go. So I can see that there was a request to this URL, again, in this case, my development environment, so not running in Azure at all. Part of the call actually included doing something on a storage account, and that was successful. But there was another portion that actually failed. And I can see what the exception was here. I can even see what the error message on the exception was. Too bad. And then I can even see, if I go down here, I can even see the call stack that has been captured by Application Insights. And from here, this is also very fancy. I use this on occasion. I can actually go ahead and create a work item for maybe a developer to investigate the cause of this problem. And I can do that either with a GitHub issue or with Azure DevOps with a work item in Azure DevOps. So there's integration there now. As you can see here, I haven't actually set up this integration for this particular Application Insights instance. I would have to do that first before I can successfully create one of these work items. So now you might wonder, well, what does the application code what does the application code look like to make that happen? And excuse me, I didn't mean to close that yet. Once again, I've done something with the GUI to make it very easy. I've essentially created the service dependency for Application Insights in the same way I did it for my Key Vault. So that's essentially configured Application Insights for me, pointing it to the proper instance in Azure. And the telemetry is being sent using an instrumentation key. And the instrumentation key is just another, actually not an environment variable in this case. That's my bad. It's, in this case, an application setting in application insights group, there's my instrumentation key. That, and there have been a few SDKs loaded for application insights. So there are SDKs again for many of the core types of frameworks that you might use, including Java. Again, I'm using ASP.NET Core, so you see ASP.NET Core. I have the dependency collector running automatically here. Because this is web application, I'm adding the web application SDK for application insights. And in this case, that's about it. If I was running on Windows Server, there are even additional SDKs that I can run to collect information about the server itself, such as CPU usage and other types of server telemetry. I didn't do it in this case because I'm just running on my workstation. I will still collect the telemetry, but it wouldn't make any sense. And then what else did I have to do? Well, again, because the SDK is so nice, the only line of code that had to happen for this to kick in is this line right here. Configuring the application insights telemetry and passing the application insights instrumentation key to it. Just that action, just this one line of code, and then of course the dependencies that I've pointed out before, have enabled everything that you've seen from application insights. I have not otherwise written a single line of code. So even when my users hit this invalid operation exception, that is the cause of my exceptions that are being tracked, that is automatically being intercepted. The fact that this exception got thrown and didn't get handled, I should say that if the exception was handled, then application insights would not capture that. But that's completely automatic. Now, I didn't demonstrate it here, but there's certainly sending any kind of custom telemetry like I was talking about, then requires only a few more lines of code to call a telemetry client and send an event or an exception by manually sending an exception or something along those lines. And all the rest, like I said, literally all the rest that you've seen collected here has come completely automatically. I can even look at live metrics. Of course, there really aren't going to be any live right now, but if you want to keep an eye on the server, it detects that map is offline, hasn't been sending any telemetry for a while, right? But if my app were to come back online, then these charts would automatically show up. So, and I have a question from Mayank. Currently, we use logging to trace execution flow, conditional checks in application insights. Is there a better way than the developer having to remember to use the logger where needed? I don't think so. For example, the stack trace that you saw, of course, is being collected because there was an exception that had been caught, or as you say, that had not been caught, but had been intercepted by application insights. The availability, for example, of the user flows that kind of works at the page level and not necessarily at the method level. So I'm not aware of any easier way to do it than to actually go in your app and tell add a particular line of code in your app to send the custom telemetry. So I hope that answers your question, Mike. Okay, so I'd like to. If you want to come off mute, Mike, and ask a question, that's fine. I'll be happy to answer it.
Yeah, I think that just confirms our understanding. I mean, I just want to make sure. Yeah. So thanks.
Okay, my pleasure. So wanted to recap a couple of the best practices that I've tried to illustrate in my code. Not that we've discussed all of them yet, but one of the key things that I'm a big proponent of is separating out or making sure that your specific implementations, for example, for queuing, or in this case, even business logic, right, are completely abstracted from the application itself. So in other words, loose coupling versus tight coupling, and then leveraging dependency injection to get the right thing. So my home controller doesn't really know anything about Azure. It has no Azure specific code in here. Neither does my logic app, my business logic here. It doesn't have any specific Azure code in it. All it knows about is that there is something called, that there's an interface, I should say, called IQ, and it will get that interface somehow. It's not even responsible for trying to figure out how to get an instance of an IQ class. And at the appropriate time, my controller, in this case here in this method, can leverage that Q object and call the method, right? How this is achieved here in ASP.NET Core is probably quite specific to ASP.NET Core. Dependency injection is pretty much built in into the framework. It's not necessarily the most sophisticated one, and of course there's still a number of third-party libraries available if you want to do more sophisticated dependency injection. But that's essentially the concept. That's the best practice. So I have one class, exactly one class in this code that knows anything about Azure, and that is one that is specifically called Azure Storage Queue, and that of course implements this interface. But other than that, there is no Azure references in here at all. So this is the only class that references one of the Azure SDKs. So that's a best practice there. Obviously, another best practice that I've tried to highlight was in the context of Key Vault, not storing any kind of secrets in your application. Now, I didn't necessarily do it with the instrumentation key here, which quite frankly, it's not a secret because it's actually exposed to the client side as well if you want to capture JavaScript telemetry. But not storing any kind of secret in your application code and offloading that to a secure store, that's a best practice that I've tried to demonstrate. And then, of course, application logging, doing that in a modern fashion without having to write a ton of code. Now, of course, Mayank's experience is a little bit different. If you want to do any kind of custom telemetry, you have to write the code for that. I'm afraid I don't have a better solution for that. Although I could think of some architectural steps that you could take, for example, decorating your methods using a custom attribute. That would be a possibility, certainly, to do something like that. But then, if this was more complex than that, you had to do something inside of that method in terms of logging. That would not help for that. Okay, so I'd love to go into discussion and Q&A. I know I've taken up a little over an hour already, and I certainly appreciate your continued attention and attendance. But if you have any questions, anything I can follow up on or expand upon, I'll be happy to do that at this time. Well, I'll take this this silence says that there are no questions at this time. Want to leave you with once again a way if you would like to get in touch with me. So if you go to this URL, oh, almost spelled it wrong. You know what? Let me try that again. ltr.mn. You might be able to imagine where I got that URL from or how I arrived at those letters. So that's how you can find my contact information. I'd love to hear from you. And if there's an opportunity, I'd love to come back and speak for the group again. Bill, I'll turn it back over to you.
Yeah, I was going to say, if there's anything that you want us to get out to the group, like contact information or slides or anything, just send it to me and I'll post it. Okay?
Sounds good.
So make sure they get everything. And with that, I want to thank you very much for a pretty interesting presentation. It's been a while since I've been a developer, but even I found it interesting. So thanks again.
Good. My
Anybody
pleasure.
Anybody have any closing comments or remarks they want to make? If not, we'll go eat supper. Okay, we'll see you all next month then. All right. Take care.
Thanks, everyone.
Thank
Thanks for
you,
having
Sven.
me. Talk to you soon. Bye-bye.
Thank you.
Hey, thank you.